Okay, so we're going to be using this program, this Vernier Video Analysis. So you can upload a video. You're actually going to upload your own video that you take of yourself at home, because of course you're not going to be videoing yourself in school, obviously. I used to use a slightly different program. We're going to use this one. It's just easier to use now. The other one wasn't terrible. This is the better one. So when you look at it, okay, you're going to upload your file. Boom, done. Now, let's say this is our file here. Okay, so I'm just going to go ahead and put this one up. What we're going to do is we're going to actually trace this ball, and I'm going to show you how to do it in a second. What we're going to do is we're going to trace it, and what we're going to see is we're going to be collecting data points, X and Y points up here, and we're going to analyze them as we go. So here we go. Every time you move it, the ball moves, obviously. The frame advances one spot. It's hard to do initially, obviously, because the ball doesn't move much. Whoa, Groom, it's super going up fast. Oh, I know, bro. I know, right? Whoa. Groom, you're amazing at that. I know. What can I say? Whoa, it's not going up as fast now. It's not going up as fast, but I feel like it's going to the right every bit as fast as it was previously. Oh, it's like we're almost getting to the top, Groom. Almost. Do a better job than I do of putting this together. It's pretty actually terrible. Whoa, we're on top. Now we're going straight sideways. Do you see that? Now we're coming down. Oh my goodness, it's almost like it's a parabola. No way. So what do we notice here? Okay, well, a couple things. First of all, the red is the X position, and notice it's linear. What does that suggest? It suggests to me that our X coordinate system is what? Say it. Say it. Yes, that's right. We are moving in a linear position. So like X equals VT, right? And specifically, X equals VT cosine theta, okay? But it's a constant. Now, in the Y direction, we see this parabola. Wait, so negative 4.9 t squared plus V sub O t sine theta plus H naught, yes? And so if we do this, okay, we have these guys here. I'm going to pause for just 1 second. I want to show you something here, okay? Here we go. So if you click on this guy right here, and then you go to apply curve fit, okay, and we're going to do it to, well, quadratic. Ooh, oh, look at that, it fit. No way. Way, bro. Negative 4.9 t squared plus 543 v 543 plus 5.14. Now, here's the issue, okay? And it's a small issue, but kind of a big deal, honestly. When we do this, we have to make sure that we are knowing what we're measuring in. So this should have been a height in meters. And so what we're seeing, this is actually measured. If you look over here, the X and Y position, you see them right there? I think it's in pixels. Okay, so we don't have a great way of looking at this. So the velocity, 543 pixels per second, what that would be, not very helpful to me. Are you with me? It's not very helpful for me. And ditto with the 514. But what I do want you to see is definitely it's linear in this direction, and in this direction it's quadratic. So if you close out this one, and then you click on the red one here first, and then if you go to curve fits, okay, and then, so yes, and then linear, and then ta-dunk. No, that's terrible. That's for the purple one. I didn't want to do the purple one. Undo, undo, undo. Sorry, my bad. So I think if I do this, close. Okay, so curve fit. Oh, bother. Cancel, please. Okay, 1 moment, please. Mr. Grimm will get you, because I can't remember how to select the other one. Okay, so if you click over here where this was, you can turn on the X and the Y, but I turned the Y's off. Okay, so then if you click out of here, now if you do apply curve fit, boom, you will see that it is in fact linear. And so the slope is 536 pixels per second, which again, not very helpful to us but whatever, it's linear though, that's important. Now, what the guy can also do is this. What would the slope be? Well, the slope is constant, right? So if you click on this, you can actually turn on the x velocity. And what you'll see is that the x velocity is these red guys, these bumpity. Well, let's turn this off. Turn those off. And what you'll see is, for all intents and purposes, it's pretty flat across here. And like Groom, it does vary. That's because Groom's an idiot when he puts his little deals on here. Are you with me? I'm going to pour at it. Okay. But you can see when you get over here, when you turn X on, you can see that in fact it is pretty much a straight line, which means you have constant velocity. Okay. Ditto, if you turn on the Y velocity, what you'll see is this. The Y velocity, okay, was going up, yes. I'm sorry. So initially, the Y velocity was positive up here somewhere. Now, initially, I kind of dinked around. So if you ignore the first few points, you go from here, is it started with a higher velocity, and as you got towards the top, it got to zero velocity. In other words, it's no longer going up, hasn't started going down yet. That's when we're at the max, and then it's going to go down. Okay, so we'll be using this software again. It's kind of sad because we can't do pixels. I'm a little annoyed by it, but life goes on. Okay, so that's just kind of how that is, and I wish we could do a better job. Now, one thing. Oh, look I just figured something out. No way, Groom. Way, check this out. Way. Okay, way, check this out. So if this was a meter stick right here, this thing was a meter stick. So 462 pixels. In other words, what I want you to do is put a meter stick somewhere in the picture. And so from the meter stick, then you'll just click on this system, and then you'll drag the end of the line to it. This is 1 meter. So now 462 pixels is equal to 1 meter. Now, if you come back over here, now we can do this right now. Sorry, my bad. I got it now. We got this. Yes. Now, if you do curve analysis, apply curve fits, and you do quadratic, because of course it is, you will see it's actually theoretically in meters per second. We have a small problem with this initial one here. So if I went back and redid it based on not including those and going from here, we would see it's negative 4.9. You shot it from about a meter in the air. Again, that's a little off because clearly this is more than a meter off the ground. But that's the idea. Okay, so I'll try another one here. Actually, I'm going to try to do this. So if when you get done, you don't like this, you can click here, and then you can delete the data sets. Perfect. And so what I can actually do is try this again, and you can play the video out here a ways, scrub it out here until he actually leaves his hand. Boom. Okay, now it's actually falling. And so now if I add points, ba-dunk, ba-dunk, again, it's just as simple as this. And so forth, and there we go. Okay, so again, apply. Oh, before you apply curve fits, now you need to put the system on. The system is there. Okay, it's already there, I guess. Apply curve fit. Boom. Quadratic. Boom. Apply. Done. So for whatever reason, this isn't working too good. You should be getting negative 4.9. I'm not real happy about that. Now, if a guy's going to do another one here, so let me click out of here. Leave me alone. So if you come out of here, come back into this analysis program. Again, it's free, so I don't know what you want for a nickel. Do you know what I mean? I mean, it is what it is, but I mean, geez. So let's say that you were doing one where, let's say you were doing one, and so here we're going to shoot something, I guess. What's happening here? Oh, no, there goes the card. Perfect. Here we go. Bring it back. Bring it back. Bring it back. So if you go add, boom, boom. Now, by the way, if you undo those, if you bring it back, or actually if you start going up here, if you start tracing it from this guy instead, and you follow the top of the thing, you might find that it's easier to do. Obviously, that's going to throw our Y's off, correct? But it's not going to throw our X's off. You can actually zoom in on this. You can see a better job of tracking. That makes sense as you go along. As time goes on, what's going to happen to our thing here? So maybe it's speeding up a little bit, okay? So the things I want you to focus on are we are going to be taking videos. I say we. I'm not doing it. You are. You are going to be doing a video of a person walking at a constant rate. Okay. So you start the video, they're walking, they walk past you. Doom, 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 doom. We should see the X axis doing this number. Boom, 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 boom. Right? The X velocity is boom, 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 straight across the page, right? Because it's constant velocity. The acceleration, which we can't graph on this, we know is 0 because it's constant. Okay. Then we're going to do one where a person's accelerating away from you. So you're videoing him going away. Then you're like, or not going away from you, rather walking past you. So you're starting off slow and then accelerate up. Okay. We should see the X start to do this. This is the X versus time. The X should go boom, 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 boom. But it should be at a quadratic look to it like this. Positive because it's accelerating away from us. Yes. And so we do that. We should see then that the velocity is linear, right? And we should see that the acceleration is constant, like maybe 2 meters per second squared. So we're going to be working on this. So you'll take your own video, you'll import them into here, going on that main page back here. So I don't know how to get back to that. I wish I could tell you, hey friends, you know what I'd like to be able to do? Yeah, but I don't know how to do it. Maybe it's back here. Oh, there you go, clear video. Is that how I do it? Nope, that is not how you do it, Jay. Reload, that is not how you do it. I don't know. Whatever. Apparently, I'm not smart enough. So one of you guys can figure it out, and we can then, yeah, right, exactly. So that's the game. Yeah, I don't know what to tell you other than that. We're gonna have to just go in and put our own new one in each time. So just restart the program every time. So on the lab, just one moment, please. I'm going to pull the lab up. Okay, so I can't find my stupid lab, so I'm just gonna do it as I speak. So what's gonna happen is this: you are going to tape a meter stick or similar to the background. That is the wall, the wherever. Okay. And then video someone walking from the side, of course. From the side, of course, right? You don't want to walk away from you because you can't see in the video per se, right? Moving at a constant rate. Okay. Now upload this video and analyze it with the Vernier app I have for you on Canvas. Okay, draw out the, well, I don't know, I take screenshots of the X displacement and velocities graphs. Do they make sense? That is, are they the right graph, linear or quadratic or constant? And do the numbers make sense? is you are walking at 30 meters a second does not make sense. Mr. Groom cannot. Annalise, good Lord. Analyze. Well, there's not two L's, but it's gonna at least he'll know what I'm talking about this time. It's pretty bad when a dumb computer, which is supposed to be smart, has no idea what the heck you're trying to say. All right, there you go. Cool. All right, number 2. Okay. Repeat part 1, but this time have the person walking do so that they are accelerating as they walk past. Answer, same thing. Show me the screenshots. And does what you see make sense? Yay or nay, and why? Yes or no, and why? Number 3. Repeat again, but this time have the person going back and forth, like walk over, then walk backwards the way you came, and then repeat. Of course, if you're going to be analyzing that is the person going backwards and forwards, their x velocities, or their x displacement rather, will be a sine curve, okay, or cosine. Either one would work. It doesn't really make any difference, okay. Guess what? If their displacement is a cosine curve or a sine curve, it's going to have part of the time when it's going away from you or going away, that is maybe to the right, and part of the time when it's coming back, that is to the left. But if it's coming back to the left, that means you have negative velocity at that point, right? So its velocity will also be a sine curve, okay? Now, a couple things to think about that. And so this is the part that I want you to think about as you're writing it up, okay? Clearly, these are sine curves. However, I want to think about this. If you start on my left, walk to the right, and then come back, start on my left, walk 5 feet to the right, and then come back to where you started from. Is this distance or displacement? Or did I ask about both? Explain. Okay. Okay, that's your lab. So what I would say is this: you are going to answer these questions with the screenshot in about a paragraph format. You're going to have another paragraph down here, answer these questions. Another paragraph with screenshots below that. This should probably take you a couple pages. All right, you probably can't jam this all into one page. That's when I say a paragraph, I don't mean a sentence. So take the time and analyze what you see. If you need help, certainly you can ask me. I'd love to do it.